Good day, everyone. This is our group assignment for Discrete Mathematics. We are from Group 8 and our choosing real life situation is school bus or delivery route planning. In these presentations, we will show the how Discrete Mathematics can be applied to the solve the problem. So let me introduce my group members. Myself, Lugni Anaprapan Shankar, Raina Raja, Muhammad Shafiq and Nur Alia Natasha. Okay, next for this part, we focus on real life situations, which is the school bus or delivery route planning. The main goal here is to the plan rotate efficiently to the whole student can pick up the while reducing time travel, distance and fuel cost. First, we identify the mathematical pattern in how the stop rotate the increases. Then we prove that pattern using the mathematical inductions. After that, we use the graph theory to the model to the situations where the bus stop are represent and verticals and rotate are the edge. So finally, we apply the minimized spanning tree methods to find the most efficient rotate so we can avoid the unnecessary parts and make overall the system more difficult. Next, I will pass to Muhammad Shafi.
Assalamualaikum, my name is Muhammad Shafiq Zisan. My metric number MS 240929584. In this slide, discrete mathematics is applied to solve a real problem, which is school bus route planning. Pattern can be observed where the number of stops increase step by step each day. This creates a sequence such as 1, 3, 6, and 10. The pattern can be represented using a mathematical formula to calculate the total quickly. To ensure that this formula is always true for all numbers, mathematical induction is used. Mathematical induction consists of three main steps: base case, inductive hypothesis, and inductive step. That's all from me. Thank you.
Hi everyone, I am Reena. Now let's move into the part graph modeling, where the things getting more interesting. We are going to use graph theory to solve the real life problem. Imagine you are a school bus driver. Your job is to pick up students from the multiple stop. Now the question is, how do you plan your route so you don't waste time, fuel and repeat the same route? This is where graph modeling comes in. According to the figure 1, we represent bus stop as the vertici, road as the edge and distance as the weight. So basically we convert the real world problem into mathematical model that we can analyze and optimize. Now talk about vertices, edge and weight. Let's break down together. First, vertices. These are simply the bus stop like stop A, stop B, stop C. Next, edges. These represent the road connecting the stop. And finally, weights. These tell us distance between stops. For example, if stop A to stop B is 2 km and the edge weight is 2. Let me ask you a quick question. Why do we need weights? Yes, because not all roads is equal. Some are longer, some are shorter. And we want the most efficient route, not just any route. So this graph helps us visualize the network, compare distance, make the better decision. Choice of graph concept, ruler path. Now comes the important decision. Which graph concept should we use? The answer is the ruler path. And ruler path is the route that passes through every edge exactly once. Let me explain why this is perfect for our situation. Think about it. The bus must cover every road, but we don't want to repeat the road unnecessarily. So the roller path helps us cover all the road, avoid repetition, save time and fuel. Let me ask you, will it be efficient if the bus keep going back and forth on the same road? Of course not. That's why ruler path is the best choice here. Algorithm explanation. Now let's go step by step like solving problem together. Step 1. Identify graph component. We list all bus stop vertices, all road edge, all distance width. Step 2. Check vertex degree. Now this is important. Degree equal to number of road connected to a stop. For an ruler path, we must have exactly 2 vertices with odd degree. The rest must be even. These 2 odd vertices will be starting point and ending point. Step 3. Choose starting point. We start from one of the odd degree vertices. Step 4. Start moving. We follow one road at a time. Never repeat the same road. Make sure we don't get stuck. Step 5. Finish the road. We stop when all roads are used. So in the end, we get a complete and efficient route. Justification of validity. Now let's justify why this solution actually valid. First, every road is used exactly once. Second, no unnecessary repetition. Third, all stops are still connected. So what does this mean in real life? Less fuel use, less time wasted, no student is missed. So overall, this method gives us efficiency plus completeness, and that's exactly what we want in real life planning.
For part C, I focus on tree and optimization. The main idea here is to make the network more efficient by reduce unnecessary connection. First, the graph is converted into a tree. A tree is a graph that has no circle, which means there is only one path between each vertex. So any repeated or redundant routes can be removed and the circle becomes simple. Next, I apply the minimum spanning tree or MST. This method select only the edge with the smallest distance while still connecting all the vertices. At the same time, it avoids forming cycle. As a result, the number of connections is reduced and the total distance becomes shorter. This is important because when the distance is shorter, it is less fuel, take less time and reduce cost. So overall, the system becomes more efficient. In conclusion, using a tree and MST help to simple the network and improve efficiency in a practical way.
My name is Shlogini and today I will be presenting on how mathematical concept can be applied in a real life situation, specifically in a school rotate bus planning. I will be covering the patterns, graph theories and optimizations. So let's imagine a simple situation. A school bus is adding more stops each day. On day 1, there is a 1 stop. On day 2, there are 3 stops. On day 3, there are 6 stops. And it keeps increasing. Now let me do one patterns. These follow the sum of nature's number that we keep editing 1, then 2, then 3, so on. Instead of the calculating every time, we use a formula to make easier. So S n equals to n time n plus 1 divided by 2. So this formula help us quickly find the total number of the stop and day. So this show a step-by-step growth the pattern in a real-life context. The next, how do we know that this formula is always correct? We usually use the method called a mathematical inductions. First, we check the base case when n equals 1. We compare the left hand sides and the right hand sides. Both are equal, so it's true. Next, we assume the formula is true or some value says equals k. Then we prove that it must also be true for the next value each k plus 1. Since the both steps are stratified, we can conclude the formula is true for the all natural number. So this ensures that our pattern is accurately relatable. Now let's move to the part B, which is a graph theory. In these situations, we present each bus stop vertex on each road connecting as the same edge. Now we apply something called a Euler path. Let me do. What you do think benefit of traveling for the each road sites? It's avoid repeating the same parts, so this helps the reduce fuel usage, save time and make the more journey more efficient. So in real life, this means a bus can cover all the route without the unnecessary repetitions. Finally, in part C, we improve the rotate event filter using something called a minimum spanning the tree or MST. This method selected on the shortest paths to remove unnecessary connections. So instead of the using all possible roads, we only keep most the efficient one that reduce total distance, save fuels and lowers costs. So to the conclude, mathematical inductions help us prove patterns. Graph theory help us model real life situations, and minimum tree spanning tree is help us optimize them. So this shows that mathematical is not just theoretical but very useful in solving a real world problem, especially in transportations and decision making.